Yeah. All right, it's done it. Now, all right, you know what I'm gonna do? I'm gonna chicken scratch this thing and go to another page because it looks. I was trying to do that, and so what I'm gonna do, I'm gonna add a page. I think. Yeah, there we go. Okay, so I'm gonna start over on this thing. Let's make sure I got the right. Yeah. So here we go.
Can you pull the screen down?
Oh, yeah, yeah. Okay.
Thanks, sir.
And I could probably, here, let me see if I can turn my body around and get some of these shades down a little bit. That's probably, I guess that's good. Kind of a halfway. So does it look okay up there? Okay. So here we got X and Y. So I'm going to try to cover everything in that one chapter. It's 9 and 10 all in one swoop and then go back to the details. So he's got this thing in there. I could bring it up, but the other day it didn't show up. Where if you're looking for the centroid of some sort of object, you have an equation like this. Where you're looking for, that's the integral over the whole area, and that's the x in there. So it's kind of like I started with this bit. And say you had a function, f of x being, I don't know the slope, but it has a slope. And then it's a straight line. So from before, we kind of figured out it was the centroid was supposed to be like 2/3 over. But we're going to start with this concept that we don't know. And so if you're looking for the d area here, you got two ways you can do it. You can do a dx, or you could do this, and I'm drawing it over here so I can erase it. You could do a strip this way and call it a dy. The problem with doing that, the problem with using a dy is you have an x represented in here. And so in this particular case, it seems beneficial to actually use the dx, and that makes things a little bit less complex. The other thing is, you've got a function that sits here. That was supposed to be a straight line in which you could figure out the height of this little thing. So if you're looking at this, the d area of that little strip is equal to the height of it, which happens to be the f of x, which you could write as y, times dx. So now that you have that, you can embed that in either one of these, or you're supposed to embed them in both. We'll first do the d area because we actually are supposed to kind of know what that is. So if you look at the integral of the d area, and I guess we need to figure out how far we're going to go. So this little triangle might go, let's see, let's call it b for base. So we're going to integrate from 0 to b of x, and now I'm going to stick in my d area. My d area is either f of x. Now in the book, he might write this as y, but in fact that y, or the f, is just cx. Now that's weird. So if you integrate this thing, you get x, c, which is the slope of this line, and x dx, looks kind of weird. So you can take the c out, and if you integrate that thing, so it was, okay, well let me do it one more time. And now Now I'll do this part. I guess I can move to the right, maybe. And so you get a C, x to the third over 3, evaluated from 0 to b. The 0 is easy. The other is not. Did I do that right? I think I did it wrong somehow.
It appears right, but I could be wrong.
Really?
Because 0 cubed divided by 3, and anything times 0 is 0. So your lower limit doesn't exist. Like it just goes to 0.
Okay. But I know the answer. Okay, so this has to be the area, and I know the answer has to be base times the height, which is c times base, and that has to be divided by 2, not 3. Okay. How have I goofed this thing up? Oh, okay, wait a minute. I have to apologize. So what I'm actually integrating, since I put the x in there, I am really sorry. So since I put the x in there, I was saying I was doing the top. The bottom. I'm actually doing the top one. Sorry about that.
Oh,
I goofed that in my words there. So I'm doing the top one. I'm sorry. So in fact, yeah, okay, so let's do this now. Do the bottom one. Sorry about that. Okay. That's on me. Let me get the eraser and erase this. And now I'll go down this side and do what I say I'm going to do, which is the D area, which in that case is f of x dx, which in that case is c times x dx from 0 to b. I am sorry.
so the C comes out front.
Yeah, c comes out front, and now I get this, right?
Over 2. Evaluated from 0 to b.
Yeah. C b squared over 2. So now the question is that, so if I have a triangle, and this is B and that's A, the area of this triangle has to be area times B over, or A times B over 2, because I lost the upper half. Okay, so let's see if that's right. So it turns out, if I look back at my triangle, then B is B, but A is actually equal to C times B, because that's the slope. So I should have this goes in there, and it should give me C, B, B over 2. And I think that's what I got. So I got that.
B times B is B squared over 2.
Yeah.
So, yeah.
So in fact, the area is the height of the thing, the base of the thing, and then half of it. Now the centroid, okay, I've sort of, so I've sort of goofed this up a little bit. So now I'm going to take the blue one, the actual centroid, I'll change the colors, not that that really matters, equals to this over that. C, B to the third over 3, over 3, C, B squared over 2. That goes away. 2/3 B. Now, That sort of makes sense because that was something we talked about before. So if you have a triangle and you want to find the centroid of the area, it turns out if this is B, it's 2/3 from the light end and 1/3 from the heavy end is where the centroid of this thing is. Now you could turn that triangle on its side and, okay, I know I called this A up here, but now I'm going to call it H. So it should obey the same thing in the other pattern. In other words, and I don't know that I did a great job of it, and that is this distance would be H over 3, and this distance would be 2H over 3. So if that makes sense. So the next question is, what if you have something bizarre? If you have something bizarre, I'll just do a bizarre one. The bizarre one might be, here, I'll do this so that we're off now to the next thing, doing a strange one. So let's just do that. We'll make it easy. We'll go to, maybe we'll do it with numbers. So we'll make this go to 2, and we'll make this y is equal to 2x squared. So it starts here and it's a parabola, and if it went on, it'd go like that. And so you want to find the centroid of it. Well, first of all, my bet is if it was a triangle, it might be 2/3 over. My bet is going to be shifted to the right of that. So let's see, just my gut feeling. So let's see what that is. X bar integral x d area and integral of d area. Okay, so I'll first deal with this one. This time I'll deal with that one. So, okay, I can take my strip dx. The height of that strip is going to be 2x squared. And I don't even know why I put the 2 in there times the x squared, except, and I'm wondering if another 2 might mess it up as far as comprehension, but we'll just go with what we got. Okay, so the d area is going to be 2x squared dx. Okay, wait a minute. dx. So that's the area of that little sliver, I guess you could call it. 2x squared dx. Okay, so 2. Now it's going to be x to the third over 3, evaluated from 0 to 2. I think I'm okay. I can put in 0, but that's not going to give me 2. Put in 2. 2 times 2 to the third over 3. I don't know. 2, another 2.
16 over 3.
That's 16 over 3. Okay, so that's going to be the area. Just as a comparison, my gut tells me that if it were a straight line, it'd be like that. So this part right here is going to be a little less area than a triangle of the same dimensions. So this height, if I put in 2 into this, I get 2 squared, that's 4. So this thing is going to be 8. So if I had a triangle that was 2 and 8, did I do that right? If I put in 2 here, right there, then that height up to that point, 2 times 2 is 4 times 2 is 8. So the area of that triangle is going to be 16 over 2. So in fact, 16 over 2 is a little, I don't know how much bigger it is over that, but that'll tell you what the area of this lost thing there is. Now, the second thing is we got to do integral of x dA, and I can just look up here and copy that down, 0 to 2, but put another x in there. So I got x to the 3 instead of x squared. And dx and equal to, okay, so 2, this time x to the 4th, this time over 4 as opposed to the last time. Okay, 2, and then 2, 2, is that right? 4 2s? Okay, so I got 5 2s. 2, 2, 2, 2, 2. Is that right? 1, 2, 3, 4, 5. So there you got 4. There you got another 4. Is that 16? And that's 32. Oh, wait a minute. But if I drop off 2 of those, they give me, okay, so I could say 32 over 4, or I could say 8 times 4 over 4. So that'd be 8, right? Am I seeing that right? So now x bar, which is that, over that, just gives me 8 over this other number. So the numbers that, I hope I did that right. So the numbers I got are this one, and then this one. Okay. So I got 8 over 6, 3. So, geez, I don't even know what that is. That's 3/2, right? I might be right.
4 over 16. 1.5.
All right. So now let's compare if I had a triangle that were 2 wide, 8 tall. Believe it or not, it doesn't matter how tall it is. If it were a triangle, this one would be 2 times 2 over 3, or 4/3. Okay, what is 4/3? That's 1 1/3, right? So in fact, if I carve out this spot and remove this, the centroid will shift to the right, and in fact this one is larger than that one. So at least I feel comfortable about that. Now,
This 1.33 and this one is 1.55.
oh,
The
okay,
distance is a little bit bigger.
okay. Now, I could even go even more berserk. Okay, so here's another berserkness. Okay, I've already brought this up. And I was kind of planning to go on to the next topic, but since I'm making this, let's say you have, this is ridiculous, but let's say you have a sliver that looks like this, in which the bottom was, okay, what did I just say that was? 2x squared. Now the top has to be, the line on the top, okay, so it's a straight line, and it goes all the way to 8, and it's 2. The rise over the run is 4. So this line on top is y is equal to 4x. Now, if I put in x equal 2 here, and 2 here, do I get the same number? Yeah. So in fact, these 2 points, these 2 curves come together right here.
X squared. Yeah, okay. Never mind. Sorry. Sorry, sorry.
Yeah, I'm barely getting it myself. So now I want to find the centroid of this ridiculous sliver. And I don't know why I'm going this way with this, but I want to know the centroid of that in yellow. Okay, let me hit the Alt key. And so it's just follow the formula. X, dA, dA. Now the first thing I'm going to do, I'm going to go after this first, because then I can just put X in there and integrate it again. However, now my sliver, and I may not have the durability, you can say, to complete this task. So the area total is equal to integral of dA. Well, let's see. Here's dx. And I am not going the same way I was before, because my area there, I need to erase that. And then, okay, my D area is equal to the height of this thing. Oh geez, this might be too much for me to do right now. So the height of this thing is, it goes from before, what is the height here? Height is one of those minus the other. And I know the one on top, this one will always be on top. This one will always be on bottom. So I'll call this y top and y bottom. So let's say y top minus y bottom. Okay, is that right? And that's the height of the thing. And then here's dx. Now I got to put all this crap in here. Y on the top is 4x. Y on the bottom is 2x squared. Oh my God, this is going to make me throw up. So now if I want to integrate this, I'm integrating it from 0 to 2. 4x minus 2x squared dx. I could individually do those. That's not terrible. Okay, 4x squared over 2. And I'm just going to do them individually evaluated. Minus 2x to the third over 3. 0 and 2. Okay, so if I stick the 2 in this first one, that's 2 times 2. But one of the 2's will go away. I'll have 4 times 2. It'll be 8, right? Okay, and the other one is 2. Stick a 2 in there. Can't get rid of the 3. So I get stuck in this top one with 2 and 2, and then 2 and 2. So it's 2 and 2 is 4. 4 and 4. Is that right?
2 cubed is 8, and then times it by 2 is 16, and then divided by 3.
Yeah, and I can't reduce it anymore.
So you're going to end up with fraction.
Yeah, now here's the beauty, is I can take this, I'll just take this, that number ends up in the denominator, and now I do this, x dA. Actually, this should have an integral in front of it. This, I can just put an extra x in there. 4x squared minus 2x to the third dx.
So you have to put an x in each part.
Yeah, because essentially it's just x times d area, and this was just d area.
Okay.
So all I'm doing is, that's the reason I wanted to start doing that one, and that first part of the lecture I goofed and I did the top one. So I always want to start here. Once I complete it, I can just slip an x in there and I got the top part on top. But, okay, so if I integrate this, oh, here, let me just integrate it. Get rid of that thing. Okay, so, ooh, uh-oh, there we go. I don't know what I did there. Okay, wait a minute. Okay, well, at least I got, okay, there we go. Now, what am I? I'm in blue. That's good enough. So I integrate this thing. 4x to the third over 3, 0 to 2, minus 2x to the fourth over 4, 0 to 2. I'm going to stick in the 2. 2. I can't get rid of the 3, so I'm stuck with the 3.
32 over 3.
Is that it? 32. Whoops. 32 over 3 minus. Okay, I can get rid of part of this. I can get rid of 2 2's there. So then 2 times 2 times 2. Is that 8? I think that's it. So now I got the necessary ingredients to figure out x bar, that sliver. And that's this on top and that on bottom. And I don't know what those numbers are. So that's the centroid, that goofy little sliver that in the first problem, or in the first or the second. I don't know. You think that's, I'm interested to see how close that is to a half.
2.6.
Is that what it is? Is that on top?
Yeah, on top. 16.
Oh, yeah. Ah. Oh, please.
So 16 divided by 3, 8 minus 16 divided by 3 is 2.66, which would put 2.66 on the bottom.
We put 2.66
On the bottom.
on the bottom and the top two.
In the top.
That kind of makes sense because I was sitting there thinking it's symmetric. Both the parabola and this are symmetric about that, so the centroid would sit right at 1, which is weird and bizarre. But when I was looking at it, I'm like, yeah, because if that's the case, yeah, I could see that happening.
That was a lot of math to figure out and describe this.
Yeah. So
Pretty
this,
cool, though.
yeah. So the second thing, okay. So this is chapter 9. This is all there is in chapter 9. The other thing that could be done, okay, I'm not sure I have the energy to do this, but let's say you had this again, and you wanted to find the y bar. And then what you got to do is set up your little slivers this way. And that is enough to make you completely barf up because, okay, if you look at your two equations, I got to go up so I can remember them. You got your top one was y is equal to, okay, 4x. Okay, 4x. And the bottom was y is equal to,
2x squared.
was it 2x squared?
Check.
Okay. Yeah, I think you're right. So this time, you got to go from the bottom one to the top one, but you're going from x. So what you do is you say x is equal y over 4, and this one would be x is equal to y over 2 square root. Isn't that awful?
Yeah.
And so now if you're looking for a y bar, guess what you do? Y d area over integral d area. And then what you've got to do, okay, so if you just work on this one, you got this little sliver here. So that little sliver, its D area is equal to, now back over here will be dy, because now you've slivered it that way. Now, okay, so your bottom function is that one.
Evaluated from,
And your top one is that. Isn't that sickening? Okay, so,
where would you evaluate that from?
well,
On your interval.
that's a good question. Hang on, let me move my thing over because, you know what, I'm gonna write it backwards. I'm gonna write the bottom, okay, so I'm going from the bottom one, that one's easy, to the top one. And that'll be your D area. But you would evaluate it from 0 to this time 8. And the reason it would be that way is because you knew this was 2. I don't know why I put the arrowhead right there. So that's 2. You stick in 2 here and you get 8. So that's how high y is. So then to find the area, let's just do that to make sure we get the same area. We should, but I'm not sure I have the stomach to complete that. Okay, so D area would be obnoxiously this over 4 minus y over 2 square root dy evaluated between that and 8. You know what? I think I'm going to do this. I'm going to let MATLAB do that. I'm okay doing some of these, but I should go ahead and do that, but I'm just getting lazy. Okay, let's see if I can find. So if I put in SYMSY, and then, what is it called? Interval? Is that right? Here, let's do this. Why? Just to see. Let's see. I want to make sure I can remember which. Integrate, yeah. INT. I typed it in right. Okay. So I integrate y with respect to y. Oop, yeah, that's what I meant. Okay, that's good. So I'm going to integrate now the function in the middle, which is y. I can't see it because it's in the way. Here. Over 4. Over 4 minus, how do I do this? Square root of y. I'll just do this. I got to put a comma y. Did I mistype that again? What did I mistype there? Oh, I forgot to put the bracket around the outside. Oh, God. So here, let's go ahead and do the evaluation. I can evaluate it between 0 and 8. Minus 8/3. Oh! Okay, so I think I put my bottom and my top on there backwards. So
the negative area doesn't make sense.
yeah, I think the reason being is I put the bottom on the top and the top on the bottom. Does that make sense? First of all, is it 8/3? Was that the area we got last time?
It was 2.66 over 2.66. It was 1.
Oh, no, that's the X. So the area was 2.66. Is 8 divided by 3? I think that's right.
Yep, that's it.
Okay. So the answer's right. It's
the absolute value of that.
Yeah, what I did is this one's the top. So I gotta take the top
Minus the bottom.
minus the bottom, not the bottom minus the top. Because otherwise, I can't, that's a positive area. That's not a negative area. So this was supposed to be that. And I can't get the minus sign to take. Why is it not doing it? What's going on?
Hit your backspace button.
Backspace? Whoa, what happened?
Whoa.
Okay. It's gone berserk. Okay, so it should have been plus, that should have been minus. Okay.
There we go.
So I goofed it up. So that's
Still comes out to
8/3.
which is about 2.6.
Yeah. So, and it's 8:40, no, it's 11:41. So what I really wanted to get to, okay, so this is almost all of chapter 9. Believe it or not, chapter 10 is this. Okay, so chapter 9, you have this term, right? And in chapter 10 is you put a square there. And all of chapter 10 deals with that. So what I'll do next time is I'll do some integrations there with that are associated with this. But then I'll try to talk about why. Why do we even need this? And of course, I can't actually answer all that, but in mechanics and materials, you'll use this thing like crazy. Well, you'll use the other one too.
Well, here's the next thing. So the x squared, is it still over the dA?
No, it's not over the dA anymore.
It's just that.
Just that. So that makes it a little bit simpler. So chapter 9 is kind of all about finding the centroid. And they spend a lot of time in a lot of different cases, but it always ends up, if it's this, the centroid is this. Now, there is some detail there, but if you want a Y, you do a Y. And then that thing I did last Friday, you start realizing, hey, wait a minute. If this is the case, x bar is equal to this, then I can break it down to composites, in which if I break that down to a summation, it looks like this on top and looks like that on bottom. So in fact, these are very similar. Now, in other words, when you go to integrate something, and you have some bars that are stacked right here, what if you only had 2 versus here's this whole function and you got an infinite number of them? Well, in the infinite number, you're doing that. But if you only have 2, why integrate? Why not do this bar and then add it to that bar? And that's kind of what, I guess I'll do a little bit of that. I did some, was it Wednesday, I think? And in that, what you do is you just say, I got a centroid there, I know where that one is, I know where that one is. And you do this summation, and you do that summation, and it's easy. So this is what's called composites, where you just have a finite number of things to sum up. And they're given, and they're pretty straightforward. Now, if you've got functions, you got an infinite number of composites, and then you're in here doing integrations, which we just did some berserk ones. So, and for that matter, it all looks the same. If you were to say, I wanted Y, you just put Y here, Y here, Y here, and it'd all be the same. For that matter, you could put a Z there, but we don't do Z's. You could do a Z, but there is a third coordinate, but we don't do that in this. But so what I'll do is I'll do some composites next time. And then what I'll do is on Friday, I'll turn around and do the x square, y square thing, and we'll look at y. And then there's some common cases that, and there's a composites there too. So you can composite those together. In other words, if you're doing this, that's great, but what if you just had 2 of them? Then you're just summing them. And you could say, you could write this as x squared a, but we'll have to talk a little bit about that one. There's some complexity in that if you're compositing these two. And actually in practice, you'll do way more composites than anything else. As a matter of fact, you could be in the engineering field for years and maybe do a couple of integrations, maybe. Most all of them are through composites. Or, you know, sometimes some people will call them sections, some people call them composites. I don't know. If you look online in most textbooks, they use the word composites. So, I guess that's that. So let's see. I did not even check. Uh-oh. Error. Your YouTube is not receiving enough video to maintain a smooth stream. As such, view. Okay, let me check and see. I did all that. I never checked the voice. I never checked the. Usually I start the. Let's see if it's still working. Oh, there it is. YouTube is not receiving video to maintain a smooth. I did some. It looks okay. That's why give me the case. I think it's good. I don't know what that error means.
Probably means cut out
Or maybe.
and just add more lag time performance.
Stream health. I've never really. Poor. Your YouTube is in. See, at the house, I don't have. Oh, so at 11:47, it said I started having lags. Oh, that was just a minute ago. Okay, so we're good. I'm going to end it and we'll go on from there.